This is the video for lesson 3.1 through 3.2, and we're solving systems of equations. Some quick vocab. A system of equations. A system is a set of two or more equations. The solution to a system is a set of values of variables that make all equations true. There are four different ways to solve systems. We can either graph, where we look for the intersections of the graph. We can use a table where we plug in values until the outputs are equal. We can use substitution, where we isolate the variable for one and plug it into the other equation. Or we can use elimination, where we manipulate the equations so that when they are added together, one of the variables cancels out. When we're graphing, there are three different things you'll look for. There can either be one solution. That means our solution is consistent and independent. That one solution, again, is at the intersection of the lines. Let me change my E color here. So our solution would be right there. If our lines are on top of each other, notice how the green line and the purple line are graphed on the same spot. This means that there are infinitely many solutions. We call this a consistent dependent solution. And again, the solutions would be every single point along that line. Or if the lines are parallel, they never ever touch, never cross. This is no solution and inconsistent. Sometimes the question will ask you how many solutions are there, and you can simply look at the slopes. If they have the same slope, you're either going to have infinitely many solutions or no solutions. So then you need to look at the rest of the equation. If it's the same equation, then you will have infinitely many solutions. If they are different equations, then they will have no solution. But that's if the slope is the same. Now, if the slope is different, then you will have one solution, consistent or independent. Let's do an example of graphing. Find a solution for the system y equals 2 minus x. This looks like y equals mx plus b, so I'm going to rewrite it to be that. Y equals negative x plus 2. That means my slope is negative 1 over 1. My y-intercept is 2, and now I can graph that. I'll start at 2, down 1, right 1, down 1, right 1, down 1, right 1, and then we can draw a line through. Let's make our line a little bigger here. Oops. Okay, and now the next line, this looks like standard form, ax plus by equals c, so we can solve using zeros. So if I want to find my x-intercept, I'll make y 0, so 3x equals 12, or x equals 4, so I'll plot a point at x equals 4, 1, 2, 3, 4. And then if I want to find my y-intercept, I make x 0, so 4y equals 12, y equals 3. And we will go ahead and graph those by drawing a line through the 2 points. Extend out. And we can look for where our 2 lines cross. Now, graphing is always an estimate. Oops, that was not what I wanted to do. Graphing is always an estimate. So, why is everything not working on me? So sometimes it's going to be a little difficult to determine exactly where the solution is. So here we look for the intersection, which is right here. The x value looks like it's about negative 1, 2.5. And the y value looks like it's at 1, 2, 3, 4, 5. And this is how we write our solution in an ordered pair. Sometimes we'll use a table of values. You have 2 equations and you'll go ahead and plug some numbers in. Maybe I plug in 15. When I plug in 15, I'll get 48.25 or 44.5. Those don't match. If I plugged in 16, I would get 49 and 46. Keep on going. You can test a bunch of different numbers. Maybe I test 20 now. I'll skip around. That's 52 and 52. So that means my solution set is 20, 52. Now that one's a little tedious because you're just doing a lot of plugging and chugging. Substitution, you need to isolate a variable. So you look at which equation would be easy to get one of the variables by itself. I can subtract 3y from both sides, and I'll get x equals 5 minus 3y. Once I do that, I can substitute this value of x in for the other x. So I have -2 times 5 minus 3y minus 4y equals -5. Now I can solve out for y. We'll distribute -10 plus 6y minus 4y equals -5. -10 plus 2y equals -5. We'll add 10 to each side and we get 2y equals 5. So that means y equals 5 over 2. Once we have y equals 5 over 2, we can go back into this equation here and plug it in. Let me change my ink color. So x equals 5 minus 3 times 5 over 2. That's like 3 over 1, and we'll multiply straight across. So x equals 5 minus 15 over 2. We need to give them common denominators. So we'll multiply 5 over 1 by 2, and that will get us 10 over 2. So x is going to equal 10 minus 15. That's -5 over 2. So when we write our ordered pair, we will have -5 over 2, 5 over 2. And that is our solution. With the elimination method, the goal is to make the numbers actually cancel out. So I'm going to manipulate my top equation here, and I can do that by multiplying a -2. When I multiply by a -2, I'll get a -6x minus 2y equals -16. We'll go through 6x plus 2y equals 16. And this one actually ends up canceling out, and we get 0 equals 0, which means infinitely many solutions. Now typically we would end up canceling out a variable, solving for y, then working through plugging that y back in, very similarly to the substitution method. But with elimination method, there are some special circumstances we can end up with. You could have a situation where it's infinitely many solutions. That's when you get a number equals itself. That's always true, so infinitely many solutions. You can also get no solution, and that's where a number equals another number that is not itself. So like 0 never equals 5, and -1 never equals 6. So in those situations, you would get no solution. Joke of the day. How many tickles does it take to make an octopus laugh? Tentacles.